So Patrick Beukema, and I'm the head of the environmental AI team at AI2 within applied science at AI2. And I like lattes from Lighthouse Coffee Roasters in the Fremont neighborhood of Seattle. And they are, I should say, incredibly good at latte art. And if you know, you know. But check it out if you're in Seattle, Lighthouse Coffee.
How are you basically continuously training that model? What does that pipeline look like?
Yeah, I'm a big believer in continuous iteration and continual improvement. And pretty much no matter where you start, right, on the sort of performance axis of a machine learning model, if you're continuously improving through whatever means, eventually you will be doing a pretty good job, right? So I think folks at least what I've seen is that a lot of teams, a lot of ML researchers and engineers sort of underestimate that feedback loop. A lot of times it's extremely expensive, right? So clearly GPT-4 or whatever is not being retrained with every thumbs down in the app. I don't know how. I think, what are we talking about? Like 100 million-ish, right? Something along those lines.
Yeah,
we're not retraining it on the fly. We also have not as large of models as GPT-4, but we are running some fairly large computer vision models which cannot be retrained as part of CI/CD. It just wouldn't make sense, right? It would be far too costly, and yet we want to be able to respond. We want to not make the same mistake twice, because our users tend to be experts in this space, right? They're generally speaking maritime intelligence experts in this specific context of Skylight. And so if they say this was wrong, as you said, we want to respond to that. What I found very useful to avoid having to retrain the big, expensive, deep net like feature extractor, whatever you're using as kind of the base computer vision model, is just put a little lightweight teaching model, a little lightweight teaching neural net on top of that model, very small, right? Like just a simple CNN, say, and the context of, so a lot of our base feature extractors, we're using Swin transformers now, which kind of the field has moved to transformers, and it makes sense. But anyways, you can put a very lightweight CNN on top of these big models that's trained by supervised learning from just literally like correct, incorrect. And we have in our platform, in the Skylight platform, there's just a simple thumbs up, thumbs down, right? And so that is enough signal to train a lightweight CNN that can be put on top of your big model, right? That is that simple model can easily be trained as part of CI/CD. I mean, it's super cheap, and we have these things running. And we've open sourced one of them. It's online. You can check it out. But it's literally just a big net and then a simple CNN on top of it, and that part is continuously retrained. And we're only talking about like 100,000 parameters or something, right? Like it's super tiny, but it's enough of a teaching signal to refine the outputs, right? So that we don't make the same mistake again.